All right, so what are we going to do with this critical point at x equals 0? We don't know if it's a max or a min, but we do know that if there is a max or a min, it has to be there. All right, so all we have to do is look at that point and see if we can decide if f prime is changing positive to negative or negative to positive. So that is what we call the first derivative test. And let's be really clear and say at x equals 0, because that's our critical point. All right, you can abbreviate FDT if you want. So here's what you do. You look at what's happening when x is less than 0 and when x is greater than 0. Now look, this really doesn't have to do with whether x is positive or negative. It just happens that x equals 0 is the critical point. So if the critical point were 4, you would be looking at x is less than 4 and x is greater than 4. But either way, what you're going to do is you're going to look at our y prime. So we know that y prime of x is equal to negative 2x over, let's leave this one this time as x squared minus 1 squared. All right? So if x is a negative number, so we do a sign analysis, S-I-G-N, sign analysis, and say what is going to be the sign of y prime for a number that is less than 0? Well, anything that's squared, see, we love stuff that's squared because it's always positive. Now, x is negative, so 2x is going to be negative, but then I have a negative here. So altogether, your y prime of x is going to be positive. All right? What about when x is greater than 0? Well, if x is greater than 0, your y prime of x is still equal to negative 2x over x squared minus 1 squared. Let's make sure my negative didn't get absorbed into my vinculum. That's what that's called, a vinculum, the line in the fraction. All right, so you can do a similar analysis. The x squared minus 1 squared, that's always positive. The numerator, we've got x is positive, so this x is positive, we've got negative, positive, positive, so a y prime of x is less than 0. All right, so what we can say is that f has a what? F has a max. We have to say where it is, at x equals 0. In fact, a lot of times what we want is the x and y coordinate. So in fact, we can say that the point, if we go back into our original equation and put in 0, we're going to get negative 1, right? So we can say, since y of 0 is equal to negative 1, we can go further and say f has a max at 0, negative 1. Now, you have to be watching in the AP exam questions of if they're asking for the y value, the x value, or both. So just watch the wording of the question to see which one they're asking you for. All right, and we're going to say because y prime, oh, you know, I was doing y and then I changed it to f. It's y. All right, y has a max. All right, because y prime changes from negative to positive. All right. So that's what f prime has. So let's see if we can take a look at that. Let's try and take a look on the old Desmos. I didn't set this up beforehand. So let's see. Our original function was 1 over x squared minus 1. So let's just see what that looks like. 1 over x squared minus 1. Behold the relative max at 0, negative 1 that we predicted. Now, what we didn't predict is that's only a relative max because there are much higher values. But these values never achieve a maximum. So this is always increasing, this is always decreasing, but to a horizontal asymptote. So there's no max or mins in these two branches. But here, there's a relative max at x equals 0 and 0.0, negative 1. And that's what our analysis showed without our having had any idea what the graph looks like. So that's pretty cool. So we'll look at some other examples next.